We're going to continue with that today. Last lesson we got to use factorizing to help us, but not everything, not all quadratics can be factorized nicely. So we have some other strategies that we need to be familiar with as well. And the next strategy we have to practice is our completing the square method. Okay, so you will remember to complete the square, you will need to find the new term that makes something a perfect square. And what you always do is you halve the coefficient of the x and you square it to find that missing number. Now, please remember, or looking at these questions, these are not equal to 0. Okay? When we have quadratics that are equal to 0, we're able to use both sides of the equation to help balance things out. These ones are not equal to 0, so I'm going to have to try and keep everything on the one side. Slightly different, okay? So, question number 1A. Complete the square with each quadratic. What I'm going to do is I'm going to leave the y equals the x squared minus 6x. Okay, taking the first two terms of that quadratic. Then I need to make a perfect square using this formula that I've highlighted in yellow. I find my x term, which is here. I'm going to halve it and square it. So half of minus 6 is minus 3 squared. Thanks, Monty, but please don't interrupt. I want to plus 9. Now, because this all has to be done on the right-hand side of the equation, I have to immediately balance that out again by subtracting 9 back off. I also have a minus 2 that was in my original equation up there that still needs to follow through. What that enables me to do is to take the first 3 terms. I'm putting them in brackets in red, but I'm just going to take those first three terms and I'm going to factorize them into a perfect square. Now, doing it the long way, you'd be looking for 2 numbers that times to give 9 and add to give minus 6, which is going to be minus 3 and minus 3. That's the long way, okay, what you're used to doing with quadratics. But knowing that it's going to be a perfect square, the shortcut is just to halve that number again, minus 3, and it's going to be the number that we put into the bracket, x minus 3 in brackets squared. Then I still have that minus 9 minus 2, which will make negative 11. Now that's all I need to do for this question. I was just practicing putting that, making a perfect square and putting it into this form. That now is in turning point form, which then means there's so many more things that I could do with that. I could find my turning point, I could sketch the parabola and find intercepts and do all sorts of lovely things. But we just wanted to practice using the completing the square first before we get into that stuff, all right? So let's practice it again. Part B. We're going to keep the y equals x squared plus 3x. I'm going to find my new term by halving the 3, which is 1.5. It's okay to go into a decimal or a fraction, and square it, which will make 2.25 or 2 1/4. Either way of writing that is fine. I immediately subtract that number back off again because I can't change the size of my problem here. I have to keep it all the same. And I have my plus 10 on the end. The first 3 terms, putting my red brackets around them again, they are going to factorize to be a perfect square. So if I halve that 3, I get 1.5. It will be x plus 1.5 in the bracket squared, and then just collect up. Minus 2.25 plus 10 is a positive 7.75. Okay, so it still works even with decimal numbers if you can keep that same process. It works for all of them. All right, next step, question 2. Complete the square in each of these quadratics. Why am I doing this again? All right, because, I'm making it a little bit harder now. I'm putting a number in front of my x squared, which is a little bit nastier to try and make a perfect square. The first thing you should always do is factorize that out. Okay, even if it doesn't go nicely, it's going to make it easier for you. So let's factorize that out. That will be y equals 2 bracket x squared plus 4x minus 12. Okay? Now that 2, we want to move it out of the way so that we can make our perfect square. To do that, I'm going to divide it over to the other side of the equation. So I'm going to have y over 2, and then my quadratic, x squared plus 4x. I'm going to stop there for a second because I'm going to start on my completing the square part now. I'm taking my first 2 terms. I'm going to halve the coefficient of that x, it's a 4, halve it is 2, and 2 squared is 4 again. So I'm going to add 4 on. I'm going to subtract it back off again. And I'm going to also have that minus 12 from this original bracket up here still sitting at the end. All right. Completing the square with the first 3 terms of that quadratic. We'll factorize. Half of the coefficient of x is 2. So it will be x plus 2 in brackets squared. Minus 4 minus another 12 makes minus 16. Now I have completed the square, but remember I moved that 2 out of the way. Now that we want to have we've got it all factorized up, we would prefer to have a y equals equation. So let's multiply that 2 back across so that y is by itself again. Y equals 2 bracket x plus 2 squared. And you also have to multiply the negative 16 to make a negative 32. Yeah, does that make sense? Let's try it again. Part B is similar. We have a minus sign in front of that x squared. We don't like to factorize things, especially not completing the square, with minus signs in front of our x squared. So like I did with the 2, factorize the minus sign out first, and we're going to move it across to the other side. So y equals, factorize the minus, x squared, it'll become a minus 8x and a plus 2. Divide the minus across to the other side. Minus y equals x squared minus 8x. Let's do our perfect completing the square now before I write that last term. Half of minus 8 is minus 4. Minus 4 squared is 16. So I want a plus 16, minus 16, and don't forget the little plus 2. That was part of my original problem. Factorize the quadratic. I still have minus y on the left. In the red brackets, half of that minus 8 is minus 4. So it will be x minus 4 in brackets squared. The last 2 numbers on the end, minus 16 plus 2, is negative 14. Okay? Only thing left to do is we want the y by itself again. So let's divide the minus sign back across the other side, which will make y equals a negative x minus 4 squared and plus, changes the sign, 14. Yeah? All right. So now that we've practiced that, obviously we want to use that to help us draw a parabola. Okay? So it says, use the completing the square method to sketch the following quadratics. So first of all, we do exactly what we've just been doing. We use completing the square to turn that into turning point form of that equation. So let's do that. We leave the y. We keep the x squared and the minus 6x. I find my new term. I halve the 6, which is minus 3. Square it is a plus 9. Straight away take it off again. And the minus 16 on the end. Factorizing the perfect square on the next line. Half of that minus 6 is minus 3. So it'll be x, take away 3 in brackets squared. Minus 9 minus 16 is minus 25. All right, that's just what we've been doing over and over again. Now for the extra parts. To sketch from here, remember we always want to know what the turning point is and intercepts, x and y intercepts. Now, by completing the square, we can read the turning point straight off of that equation. The x value comes from here, so the x value will be 3. Remember, it's always the opposite sign, 3. And this number here is your y value, minus 25. So straight away, let's write TP for turning point. Positive 3, negative 25, straight from that equation. Then we want to find our intercepts. So we can sub in when x is 0 and when y is 0. When x equals 0, we're going to get y equals 0 minus 3 in brackets squared minus 25. Okay, that's plus 9 minus 25 is negative 16. Okay, then I want when y equals 0, I'm putting this into maybe I should highlight it yellow for you. This is my formula I'm substituting into. When y equals 0, I get 0 equals x minus 3 in brackets squared minus 25. Now don't expand that all back out again to try and find x. Having it factorized is going to make it easier for us. We want to move everything away from that x. So first of all, the 25. X minus 3 in brackets squared, it'll become a positive 25. Then you will square root to get rid of the squared. So x minus 3 equals, square root of 25 is 5, but it will be plus or minus. And then I need to still move that negative 3 across to the other side. So it's plus or minus 5 plus 3. Now that actually makes two very nice solutions. I don't need to keep it like that. First of all, I do positive 5 plus 3 more. That's going to be x equals 8. So I know I'm running out of room. I hope you've got more room than I do. X equals 8. Or the negative one. I go negative 5 plus 3 is negative 2. So there is two x-intercepts, which you probably will expect for a parabola, right? So now we have all the information that we've squeezed in there. Let's draw a sketch. Hopefully you've got some space on the right. We have to go quite a way down, so I'm putting my x-axis quite high. My turning point is a good place to start. That was at 3 minus 25. So I'm going to put that, it's a sketch, so it's approximate. 3 minus 25, down there. Then I have my y-intercept is at negative 16. So up from 25, that seems reasonable that one there might be minus 16, y-axis. And my x-intercepts are minus 2, so x-axis up here, we're at minus 2, and a positive 8. Try and space it so that it does look symmetrical. You don't really want a wonky looking parabola. All right, from the turning point, coming up through your y-intercept, through your x-intercepts as well, there is our parabola showing turning point and intercepts. All right, next page. Shh. Year 11. You don't need to talk, you just need to watch and listen. Shh, Liam. Next page, B. A harder one. It's harder because everywhere I look around the room, I'm seeing little bits of conversation. Please don't. We want all of the time we can get to get through our questions and then on to the exercises. Please don't waste everybody's time. This question is harder because we have a 2 in front of the x squared. So like we did in the practice ones, we're going to move that 2 across the other side, but I have to factorize it out first, okay? So make sure it comes out of all of the terms. So let's factorize out the 2. 2 bracket x squared plus 4x minus 12. That's y equals. Divide the 2 across to the other side. So I'm going to have x squared plus 4x, and let's start on our completing the square. Halve the 4 and square it means I need to add 4 and take it off again. And the minus 12 is still there as well. Taking the first 3 terms, we complete that square, factorize it up. It will be x, half of 4 is 2, so x plus 2 in brackets squared. Minus 4 minus 12 is minus 16. Getting the y back by itself, we times the 2 across, so y equals 2 bracket x plus 2 squared, and timesing the minus 16, we get minus 32. We can read off our turning point, just like last time, we can read off our turning point straight away. It is the opposite for the x value, so it's going to be minus 2 for the x, TP for turning point, minus 2 for the x, and the number on the end, the minus 32, is your y value. What does that 2 do?
Oh, it judges it from... Makes it
wider or narrower. So it doesn't move the turning point. We don't need that 2. We don't need that 2 to help us with the turning point. All it's doing is changing the width of the parabola, and that's why that's there, okay? Once we've found the turning point, we still want our intercepts. So I'm going to try and keep this, got only a little bit of room here. So we want to put in here when x equals 0. If x equals 0 into, I'll highlight it yellow again for you, into this equation, I have 2 bracket 0 plus 2 squared minus 32. You just sub that in. Is everyone okay with that part? And you will get minus 24. Let me get rid of the highlighter part. The longer one is when you want to do when y equals 0, because that's when we have to rearrange our equation, which means we have 0 equals 2 bracket x plus 2 squared minus 32. And we've got to move everything away from that x. Again, remember, please don't expand that out or you're not going to be able to find your intercepts. Okay, so add the 32 across. We will get 2 bracket x plus 2 squared equals 32. Divide the 2 out the front. You can't square root while that's in the way. So that's x plus 2 squared equals 16. Then I'm going to have to come a little side bit over here, running out of room. Square root of 16 is 4. So x plus 2 equals 4, but that's plus or minus. So when we square root, we have a plus or minus. And then subtract the 2 to the other side. So finding those out as individual solutions, a positive 4 minus 2 is 2. Or, using the negative solution, negative 4 minus another 2 is minus 6. And we have to put all that on a graph that we hopefully still have room for. So again, it's all happening below that x-axis. X and y, labeling those. My turning point was at negative 2, negative 32. Let's put that about here. Make sure you write down the coordinates on it. My y-intercept was at minus 24. That's going to be there. My x-intercepts were a positive 2 and a negative 6. And connect it up. That's it. Question 4 is a slightly different type of question. Does everyone finish writing that one down? Question 4 says, write down the family of quadratics that has a vertex at minus 2, 3. We can put that into turning point form, okay? We know that if the x value is minus 2 there in that point that I've been given, then it's going to be y equals x plus 2 in brackets squared. Always change the sign, because remember for the x value, it's always the opposite sign when you put it into that bracket. The 3 from here, that is telling me the number that I have to add on the ends. That's going to be a plus 3. Now, what does this word family mean? Why am I asked to find a family of quadratics? The reason this is going to be a family is because I could, even though the vertex is locked in, I could change the steepness of that parabola. So what I can do to demonstrate that is put a letter, let's choose an A, in front of that to represent that we could change the steepness of that parabola. And that's why it's a family. They all have the same vertex, but we can change the steepness of them. So it's not one specific equation, it's many of them. Part B. Find the equation of a quadratic that has a vertex of -2, 3, same vertex, if x equals 4 is one of the zeros. So we already, that means it's one of the points. We already know that it's going to look something like this, right? That was the same point as before. So let's write that down. We know it's going to be y equals a x plus 2 in bracket squared plus 3 because we're using the same vertex as before. That extra bit of information is telling me that if x equals 4 is a 0, that means it's an x-intercept. Remember when we said zeros mean the same thing as intercepts? We talked about that last lesson, I think it was. So I can substitute that as a point. X is going to be 4 and y is going to be 0. Okay, that's what it is, x-intercept. X value is the 4 and it's y equals 0, so it's right on that axis. If I sub that in, I can find the A. Let's do it. So y is 0. We have A bracket, x is 4, so 4 plus 2 in bracket squared plus 3. Calculating this bracket, I told you the answer. 4 plus 2 is 6, and 6 squared is 36, okay? So that becomes 36a plus the 3 on the end. I'm trying to get the a, so let's move everything away. First of all, subtract the 3. 36a equals a -3, and dividing by 36, we get 3 over 36, which simplifies to -1/12. Remember that not all your answers are going to be nice ones. All right? The goal was to find the equation of the quadratic, not just a. So I want you to then write the full equation out again, putting the correct value of a in there. So over on the side here, we can go, therefore, y is going to be equal to -1/12 x plus 2 in brackets squared plus 3. Last bit. Find the equation of a quadratic that has that same vertex, -2, 3, if the coefficient of x is a 1. All right, let's start with our equation. Y equals a bracket x plus 2 in bracket squared plus 3. We know that's our starting equation when we're given that vertex. This time we're after the coefficient of x. So I'm going to have to expand out that perfect square to find my x. I need my x all by itself. So leave the a out the front for a minute. Expanding the perfect square using the short method means x times x is x squared. Then you times the two things in the brackets together and double it. So 2 times x is 2x, and double that is 4x. Still lots of people forgetting that middle term when you're expanding these out. And then last term times by itself, 2 times 2 is 4. And we still have that plus 3 sitting on the end. Expand that out again so that our a is expanded into that. We have ax squared plus 4ax plus 4a plus 3. What I wanted from all of that work was this term here. I wanted to know what was in front of the x, because it says in the question that the coefficient of the x has to be 1. So in front of my x, I have got a 4a. So that means that the 4a has to be equal to 1. I can find out what A is. I divide by 4. A is going to be equal to 1/4. And that's given it all away. Now I know what my starting equation must have been. I can put that back into my equation, my starting one. Y equals, if A is 1/4, then it's going to be 1/4 bracket x plus 2 in bracket squared plus 3. So you get to sketch some parabolas using completing the square, but you also get to have some other types of fun there as well with these ones here at the end.